So in our section 2 extra practice, we're going to go over the two methods to solve systems of equations algebraically, which are substitution and elimination. So I've go ahead and I've copied the steps directly from the notes and I've put them right here so you can look at the steps individually. So if you're solving using substitution, the main thing is that one of your equations, you have to solve for one of the variables and then you substitute it into the other equation, solve for your variable, then plug that number in. For elimination, both of your equations have to be in standard form, so x and y are on the same side and the numbers on the other. You multiply one or both of the equations by a value so that they have the same coefficient but opposite signs. Add the equations together, solve for your variable, plug it back in to solve for the other one. So I'm going to do an example of each. So our first system is x plus y equals 12 and y equals x plus 2. Anytime I have an equation that's already y equals or x equals, that's an indicator to me that I'm going to use substitution. So I have that y equals x plus 2, and I'm going to substitute that in for y in the first equation. So it becomes x plus 2 equals 12. I'm going to combine like terms. I get 2x plus 2 equals 12. Subtract 2 from each side. We get 2x equals 10. Divide by 2, and x equals 5. Now that I know x, I can plug it into either one of my equations to solve for y. And since I already have an equation that's y equals, I'm going to plug it into that. It says y equals x, which is 5, plus 2, so y equals 7. And the nice thing about solving a system of equations algebraically, you don't have to write your final answer as a point. You can leave it as x equals 5, y equals 7. If I were to write it as a point, it's always in parentheses, x first, then comma y. So I would get 5, comma 7. The second system of equations is x minus y equals negative 6 and x plus 2y equals 15. So I am going to solve this system using elimination. So when I'm trying to determine which variable I'm going to eliminate, I always try to eliminate the easier one. So when I'm trying to eliminate a variable, I look for one that already has opposite signs, but I look for the variable I can also eliminate by multiplying only one equation. So if a variable already has opposite signs, but it would mean multiplying both equations by a number to eliminate it, I'm going to choose the other variable. So in our system, my x's already match. They're already both 1x. But my y's already have opposite signs. One's a negative y, one's a positive 2y. So it wouldn't be difficult to eliminate x first. It also wouldn't be that difficult to eliminate y. But eliminating y means I don't have to multiply by a negative. So that's the variable I'm going to eliminate by multiplying the first equation by 2. So my first equation becomes 2x minus 2y equals negative 12. And this second equation doesn't change. X plus 2y equals 15. Now we're going to add the equations together. The y's cancel. 2x plus x is 3x. Negative 12 plus 15 is 3. Divide by 3, and we get x equals 1. Now that I know x, I'm going to plug it into one of the equations to solve for y. And I'm going to choose the second equation because when I'm plugging my value that I just solved for back in, I try to choose the equation that has the least number of negatives. So 1 plus 2y equals 15. Subtract 1. You get 2y equals 14. Divide by 2, and y equals 7. So my solution written as a point would be 1, 7. Okay. If you had chosen to eliminate x here by multiplying one of the equations by a negative, You would have solved for y first, getting that y equals 7, which you then would have plugged in to solve for x, and you would have gotten that x is 1. So it doesn't matter which variable you eliminate first, that you will always get the same answer no matter what. Please let me know if you still have questions over substitution or elimination.